So my triangles here are 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8. When I say that's 4 and 8. And then I'm going to have, and so this would be the same. So it'd also be 4 and 8 on that side. And then I'm going to have drawn here, triangle, triangle, and this is going to be 3 and 5. So my first step is finding the hypotenuse on all of those right triangles I just drew in, which I don't need to do 4 times because this is the same triangle as that and this is the same triangle as that. So I have to do the Pythagorean theorem twice. Okay, that's kind of step 1, draw this in. Now for each triangle that I have, I need to do the Pythagorean theorem, which I'm always drawing in the legs of the triangle. So for this particular situation, it's always the hypotenuse that's missing. Okay, and 9 plus 25 and giving me 34. I have to take the square root of 34. I don't think we can simplify the square root of 34 in any way. So it's just going to stay square root of 34 on that leg. And it would be the same over here, or sorry, on that hypotenuse. And then I have to do the Pythagorean theorem on the red triangle. 4 squared plus 8 squared equals x squared. Oh, what am I doing? 16 plus 64, which gives me 80 equals x squared, or the square root of 80. Square root of 80 can be simplified. What perfect square number goes into 80? What perfect square number goes into 80? So 4, 9, 16, 25. Which one divides evenly to it? 16, yeah. So 4 divides in evenly, but it's not everything that I can take out. I can actually do 16 times 5, or this is going to simplify into 4 rad 5. Okay, so that's a lot of kind of upfront work. Now that I've done that, now it's always going to kind of feel the same, how perimeter and area work out. So perimeter being adding all the way around the triangle, I can either write each side out, or because these are the same, I can say I have 2 sides that are the square root of 34, plus I have 2 sides that are 4 rad 5. So the only reason I'm multiplying here instead of writing it out is instead of writing this twice, I'm just saying I have 2 of these and I have 2 of those. And so that means I have 2 square roots of 34 plus 2 times 4, I have 8 square roots of 5 units. That's my perimeter. Adding each side of that 4-sided shape. Now for the area, that's where I like to draw a visual. I'm going to use this larger rectangle that I've drawn in, which is 9 by 11. Adding 4 and 5 together here, 8 and 3 together there. So I'm going to have that rectangle that's 9 by 11, and I need to subtract out the 2 red triangles that I drew in, and I need to subtract out the 2 blue triangles that I drew in. And I like to just write the dimensions down here. So the red triangle had legs that are 4 and 8, and the blue triangle had legs that are 3 and 5. Okay, so I already have my dimensions down here. Now I don't even have to look up here again. So I know that this is 9 by 11, 4 and 8, 3 and 5. So to find the area, all I needed to know is my area formulas. So for my rectangle, it's just base times height. 11 times 9 is 99. For my triangles, it's 1/2 base times height, the 2 legs, minus 2 times 1/2 base times height. Okay, and anytime I have that doubling of my triangle, that's just going to get rid of the 1/2. So I'm going to get 99, running out of space, minus 32, subtract 15. And I'm just going to use my calculator. Oops, 99, subtract 32, subtract 15, giving me an area, and out of space a little bit, of 52 units squared. Okay, so anytime I have this where I draw in that rectangle around it, I'm then going to subtract out any figures I drew in. It's not always a triangle, so we'll see as we get further in this, like maybe I have to draw in a rectangle to fill it in. But I'm just subtracting out the extra. Okay, so 5 is up here. This is parallelogram. I want you to try this challenge, which is a trapezoid. And again, it's not really any different, right? We're still just going to draw in. But what you'll notice, I want to use a different color, is that this time the opposite sides, it's not the same triangle that I drew in. Okay, so the reason this is a challenge is this triangle is 1 by 1, 2, 3, 4, 5, 6. You have to count that last unit there. And this triangle is 1, 2, 3, 4 by 1, 2, 3, 4, 5. And then I'll have a different triangle still down here. And I'm just trying to create a box around the figure. I'm boxing it in. Okay, but that's going to be a different triangle. That's going to be 1, 2, 3, 4 by 2, 4, 6, 8, 10. And I think the top is even a different triangle. And now I've boxed it in. So I've created a box around the outside. But for this particular one, 1, 2, 3, I think. 1, 2, 3, 4, 5, 6, 7. Okay, for that particular shape, I end up having 4 different triangles that I need to subtract out. So for this one, I'm going to give you more time, and you have triangles on the back. If you get to them, just find the area. So that means I don't even have to go through and find the hypotenuse. If it asks me just for area, I don't need to know these lengths. But practice, what would it look like to find the area of this figure? Okay, just find area. Okay, so I'll give you 5 more minutes or so. Keep working. Try a triangle on the back if you have time. If you haven't already. I'll zoom that in on that one if I can. A bit closer. This thing is so difficult. Woo. Too close. It is a little zoomed in so you can see the numbers a little better. This is a 7. Okay, so what I have, and I kind of didn't have a ton of space. So 1/2 5 times 4 would give me 10. 1/2 7 times 3, 10.5. 1/2 6 times 1. 1/2 4 times 10. And what I like to do, sometimes if I have a lot of things I'm subtracting, I just collect all of these up. So in total, I'll subtract 43.5 from 99, just so that I don't end up pressing the wrong button in my calculator somewhere along the way. And that gave me 55.5 units squared for my area. Okay, now let's look at the triangles real quick. I think I left one for us to look at. Triangles are essentially the same thing. Now, similar to that challenge problem, zoom this back out. On this first one, when I draw in to create that box, I end up with 3 different triangles. So it takes a little bit longer when I do the area. I have to subtract from that box I drew in, red, blue, and yellow triangle separately. And you can look at answers there. It still asks for perimeter and area. Now this one, because it's a right triangle, you could have drawn the box in and done it exactly as that first one. It's laying flat on the graph. So this is already a right triangle. I can just do that to find the hypotenuse. It's already a right triangle. And then add them up. There's my perimeter. And then for my area, it's a triangle, so I already have the base and height. So I just did 1/2 base times height to get the area. If you didn't see that, could you have drawn in the box and done it the other way? Sure, you still would get the same number. Okay. This one just asked for the area. I kept this one to look at together. So again, same idea. I'm gonna draw in triangles around this. So let's see. 2, 4, 6, I think 7 units here. You can tell me if you have something different. 2, 4, 6, 8, I think 7 and 11. Triangle here. 2, 4, 5, 2, 4, 6, and a different triangle here. Okay, so the only thing is sometimes depending on the shape, just going to be a little bit more work to do the area because I don't have multiple of the same triangle. 2, 4, I have 5, 2, 4, 6, 8, and I think 12. And it just asks me for area. So if it's just asking for area, I don't need to go through and find the hypotenuse. It actually speeds things up quite a bit. So now I just need to write out what I'm going to have here. So to find my area, I have a rectangle that's 11 units this way and 12 units this way. So 12 by 11 rectangle, right? And I'm going to subtract out the area of the red triangle, and I'm going to subtract out the area of the blue triangle, and I'm going to subtract out the area of the yellow triangle. And what I do is I just draw these dimensions in, so I'm not even going to look at the picture again. I'm saying, okay, base and height here, 7 and 11, 5 and 6, and 5 and 12. And so now I just need my area formulas. So this is base times height. My triangles are 1/2 base height. So I'll give you a minute to work that out. I'll show my work up here. Use your calculator.
Are these triangle ones in the test?
Oh, absolutely. We're going to look at shapes that are way funkier than this. And so you get a decimal here too, right? Because you get 11 times 7, it's going to give me 77, and half of that, 38.5. And so here I could just type this in, or I could add these up and subtract once. Let's see. I get that the total area of that triangle is 48.5, and don't forget your units squared. Square units. Okay. So it's kind of always the same, right? Doesn't matter the shape, the strategy stays similar. We are going to look at some other shapes today. Really, it's going to be fairly similar today. I think one of them we absolutely want to talk about because it will start to look a little bit different. So find your notes. We're just going to, I think it's 3 more, really. But just to show you, like you're gonna be going like way more than just regular shapes. Okay, you'll have all sorts of, or like this crazy guy. Okay, but the strategy is gonna stay the same. Okay.
That's not test 2.
What?
That's not test 2.
Oh yeah. Quiz. Okay. So we have our formulas again on the top. We've already done parallelograms, so really, I feel like I can let you work here in terms of finding the perimeter and area of these first 2 parallelograms, okay? So same as what we just did, four-sided shapes, do not move on to the one on the back, okay? I'm gonna give you some time to look at the first one. That one's easier. And then we'll go over that. We'll do the second one, we'll go over that, and then we'll do the third one together.
Is that the notes?
Yes, sorry, notes number 2. Okay, these first two, I'm very confident you can do without me having to talk you through the notes. And I'll start filling in my work on the first one in a minute. Okay, so here are the dimensions I get on this first one. So perimeter, I'm just adding up my sides. 5 plus 10, 15, 5 and 10 gives me 30 units all the way around. Okay, perimeter, I'm just adding up on the actual shape. Make sure you don't add the outer rectangle that you drew in. On the actual shape, adding up your sides. Then for my area, I have this rectangle that's 13 by 4, and I'm going to subtract 2 triangles that are 3 and 4 for my legs. So I'm going to have 4 times 13 for the area there, subtract 2 times 1/2, 4 times 3. So the biggest thing is just remembering to switch formulas for triangles and rectangles. 4 times 13 gives me 52. 2 times 1/2 is just 1. So I'm subtracting 12 from that, giving me 40 units squared for my overall area. Okay. Now the second parallelogram is trickier. You still want to find the perimeter, and you're going to have to do the Pythagorean theorem here. You won't have a triple. Okay, so you're going to draw in, same idea, right? So I'll give you some more time to look at this one. I will say that your test is larger grids like this one. Your homework, that made it hard. The homework was so tiny, the grids. Okay, so give you some time. Find our hypotenuse. Something on the bottom of my shoe. Radicals that I'm adding up, I'm just collecting the ones that are like. I can add these two together. I have 1, 2, I have 2 all together. I have 2 more, I have 4 all together. And if I had units that weren't radicals, that would just be in there as well. Okay, separate. Then for my area, I have 9 by 8, the rectangle that I drew in, and I'm going to subtract 2 triangles that are 4 by 6 and 2 triangles that are 2 by 5. Okay, so I have 9, 8, so 72. Subtract 2 times 1/2, 6 times 4, minus 2 times 1/2, 5 times 2. And again, because I have these double, the same triangle twice, those are just going to cancel each other out. 2 times 1/2 is just 1. We don't want to kind of get in the habit of always doing that. We want to check and make sure that that's the case before we start canceling out that 1/2. Minus 10. Okay, so then I just end up with 6 times 4 and 5 times 2. And I subtract that from my outer rectangle. Oops, sorry, I typed it in wrong. Gives me 38 units squared. And when you start to work, like if you're worried about the assessment or whatever, you can also kind of afterwards, like ask yourself, is that logical? You could count all the whole squares in here and kind of see how many like if you get a number that's outrageous, and certainly there's not that number of squares as the area, then something's wrong. Okay, so 38 units squared means there's 38 of these cubes in there. So if I wanted to check myself, I could count up like whole cubes and how many half cubes I have and see if this is like close to what it looks like, okay? But it shouldn't be way off. Like if, for example, if this just said 3 units squared was my answer, that wouldn't make any sense. 3 units would just be 3 of these. Okay, so 38 means there's 38 of those boxes in here. Some obviously broken into partial parts there. Okay, let's look at our last parallelogram. So this is what happens here. So looks the same, right? But then watch what happens when I draw in my triangles. I have a triangle here. I have to go from the edges of that side. Okay, so drawing down, over, do the same thing up here. Okay, so I have this 1x3 triangle on the ends. And on the sides, I draw in a triangle. Drawing the same triangle over here. Four by 4. This is also a 4 by 4. Well, I drew in the triangles, but I didn't create a box around my figure. Okay, you see that? It looks different than the other ones. I drew in right triangles off my sides, but it didn't create a box. So what I need to do is I need to complete that box. So I'm also going to have a small rectangle here that's 1 by 4. And I'll have a small rectangle here that's 1 by 4. Okay, now I have a rectangle outside. And so if I was to just find area, let me talk about area first. Now, when I do the area, I'm going to have the rectangle I created was 7 units by 5 units. And I have 2 red triangles that are 1 and 3. And I have 2 blue triangles that are 4 by 4. And then I have 2, ran out of space there a little bit, small skinny rectangles that I also had to add in that are 4 by 1. Okay, so now when I subtract to find this area, what we're trying to find is what's this area in here. I find the big area and I subtract these triangles, I subtract those triangles, and I have to subtract these guys too. Okay, so it's just really adding in, and it's the first time we've seen, it's not just triangles that we're working with. So then we have to be really careful with our formulas. This 7 times 5, 35, then I'll have 2 times 1/2, 3 times 1. 2 times 1/2, 4 times 4. Minus 2 times just 1 by 4. Okay, this is a rectangle. So it's not 1/2 base times height. It's just I have 2 of these rectangles. That's just base times height. So you just have to be really, really careful with using the correct area formula. Okay. So for the triangles, again, 2 times 1/2, it's going to cancel. So I get an area of 35, subtract 3, subtract 16, subtract, nothing's going to cancel here. 4 times 1 is 4, times 2 is 8. 35, subtract 3, subtract 16, subtract 8. Which gives me an area of 8 units squared. So this one's an easier one for me to maybe check if that's reasonable. Okay, and I can kind of go through and see sometimes what I like to do, if I count that as 1, 2, 3, and then I start counting halves. So I count this as 4. Maybe I count this as about 5, 6, 7 here. Okay, so it looks like I have about 8 boxes there. Like, yes, I had to combine, but you see what I mean? How I can kind of check that afterwards? 8 units squared means I have 8 of these units in there. Okay, so you can kind of do a quick count using an estimate of what halves can kind of make a whole unit there. I'm not going to ask you to do perimeter. Okay. What I want to talk about real quick, let me stop sharing. and reshare. Is tomorrow. Oh, God. Hold on. There's my geometry. Is this week? Yeah, okay. So tomorrow I have it as an asynchronous work day, but you need to complete and submit homework 42 for attendance in classroom. Okay, and homework 42 is gonna look a whole lot like, where'd my homeworks go? Homework 41. Okay, but it's going to have these parallelograms, and you may run into one that you have to draw in, I think on the back page, that you have to draw in some boxes as well. Okay. Just pay attention to the directions in terms of what it's asking you for. Oh my God. This thing gets in the way of my, well, you can see it, the other kids can't. Like the first three, it's asking you for perimeter and area, but then on the back, I think it just asks you for area, which is faster. You don't have to find the, you don't have to use the Pythagorean theorem then. Okay, so 4 and 6, it's just area on the back. So just make sure you read the directions. I'm not going to make you do the classwork for this just because we're cutting it a little close. So if you do want to spend 5 minutes, you could get a jump start on this homework. I don't want you to pack up right now, so you can choose. There's classwork. You could practice some more stuff with parallelograms. I was going to break it down a little more, but with 5 minutes, it's not worth it. Okay, if you want to practice here, or you can start the homework with the 5 minutes that we have left. Okay, let me do this.